Good morning, everybody. My name is Vishnu Dutt. I have Punish and Prashant with me, which are going to help you with the labs, right? But we have today session number six. Session number of six of what? We are learning pretty fundamentals of uh, computer networking in a course named as Cisco Certified Network Associate, right? It is pretty well-known certificate from Cisco, certification from Cisco. If you do that, it is going to great. It is going to be great. So if I say what is the agenda of today's session, what we are going to learn in next 2 to 3 hours, right? The agenda is, as you know, we were talking about VLANs, and now we are pretty good with respect to VLANs. But believe me, there are few things which you need to understand more. Okay? What is going to happen if you have multiple switches and if you create VLANs across multiple switches? How these VLANs are going to talk about, right? How these VLANs are going to send message from one to another. Then we are going to talk about uh, the concept of .1q or 802.1q and native VLAN. Do not worry about it. These are just the names. But in the first point, we are also going to discuss why behind the concept of trunking and native VLAN. So it is going to be with you. We can send data as well as voice on a particular interface, and how to do that I will be showcasing you. Then we will be having some requirements from the customer, and believe me, you are now in the position of design a network, a pretty small network based on a customer requirements, right? And we will see how to do that. So this is going to be your start with respect to design. We are going to collect the requirements. We are actually doing the brainstorming around it, and you are more than welcome. Just raise your hand if you want to have some point to consider, right? So we are going to talk about how to design a network based on VLANs we just learned about, right? So as I mentioned that from now onwards, whatever we are going to do, we are going to make the TCP/IP more efficient. VLAN is one of the way, right? Then we are going to discuss about some of the serious problems with layer 2 networks. Yes, there are. There are some problems when you have multiple switches, right? Maybe 3 or 4 switches connected together with different VLANs or a single VLAN. If that is the case, believe me, there are going to be some serious problems. What are those problems? We need to understand those problems first. If we understand those problems first, then probably we will try to solve them. And believe me, there is one problem of looping which can be solved by spanning tree protocol. We will be talking about it. Do not worry, right? And then whatever you see from spanning tree onwards, you are going to get it once you get the concept of spanning tree protocol. In the also, if I say Punish will be guiding you how to create these VLANs, how to come up with the .1q trunk also, right? And first of all, what is that? So if you give me next 2 to 3 hours, I promise you that you are going to be pretty good with respect to these concepts. And these concepts are important. These concepts are your core fundamental knowledge of networking. Having said that, let's move to our first board where we are going to talk about multiple switches scenario, right? So if I remind you yesterday, we need VLANs, right? Because we do not want to send these broadcast frame, the ARP frame, right? Outside my uh, outside my domain, right? And that is why we have divided these domains, right? So if we divided this broadcast domain, we come across VLANs. And if you didn't get my last statement, broadcast domain, what this guy is talking about, it means that either you were not in yesterday's class or you haven't seen yesterday's recording, right? I agree that I was not able to put this recording yesterday, but I will definitely do it today, right? Because the recording is up and running. And one more thing, if I tell you, Whoever has registered till day before yesterday with cisco.com ID, right? Out of these batch means I could see 74 people here, and whoever has registered with cisco.com, right? Then they must have the access. We have exclusively provided access for 50 people who have registered, not today, not yesterday, but day before yesterday, whatever you have registered. Now those have the access to the website. Okay. Now what you need to do is just log into the website, which is bridgewire.com, right? With your credentials, whatever you have provided. I have asked you to not give the Cisco's password, but yes, Cisco's email ID would be okay, right? So just log into this and just go to on CCNA course, right? There is a course with the name Cisco Certified Network Associate or CCNA. You just need to click on enroll, right? It won't ask you anything like money or something. Just enroll and start learning. Here you are going to get all the videos in a structured manner, and whatever we have, we are doing in the hands-on lab. Those are also be coming into the hands-on portion. For example, yesterday's Mr. Dhaval had guide you with respect to how two switches or how you are going to connect multiple computers with a switch, how to make them communicate, right? All these things are going to be in hands-on section, right? So having said that, you have the access, and I'm pretty sure that out of means we have here around 100 people, and I'm not sure that whether you all have registered or not. Just registered with this website, and probably we will do another round of giving you access maybe in a couple of days. In the meantime, you can all go to YouTube, right, to learn everything. But by the way, on the bridgewire.com, I will be providing you access of some of the Wireshark captures which we were doing, right? Some of the configuration files which you can directly import into your packet tracer to work more on it, right? So this was the information I wanted to give it to you, right? Having said that, let's talk about what is going to happen if we have multiple switches. So if you can see here, we have two switches, switch number one, switch number two, right? I would request everybody to please be on mute if you are not. And if you have question, please raise your hand. So we have two switches, switch number one, switch number two, and I have created a VLAN 10 on switch number one. I have created a VLAN 20 on switch number one. And as we were discussing yesterday, these VLANs are actually your networks, right? So I can say that this VLAN might be 192.168.10 dot maybe 0/24, right? And this is 192.168.20.0/24. It means that these are going to be having 254 legitimate hosts, right? And maybe this IP address could be .10, .20, .30. If I say .10, the meaning is 192.168.10.10. This is 10.20. This is 10.30. You all know, right? Similarly, these guys are also going to be 20.10, 20 dot maybe 20, and 20.30. It is as simple as that, right? But presume this switch is only having, say, 24 ports, and now there is a requirement. There is a requirement that we need at least 20 people in VLAN 10, and we need 20 more in VLAN 20, right? These two VLAN could be anything. Maybe this is the marketing VLAN, this is engineering VLAN, and now my company is growing. If my company is growing, then it means I need some more people. Maybe I'm hiring more in marketing. Maybe I'm hiring more in engineering. Previously, it was okay. I have 3 computers in engineering. I have 3 computers in marketing. Only 6 people were there. But now my company is growing. And if my company is growing, I need more people And that is why suppose I need 20 in marketing and 20 in engineering, right? So what I'm going to do is I will be having another switch of 24 ports, suppose. So there are going to be 48 ports now. Why? 24 ports on switch 1 and 24 ports on switch 2. It is going to be 48 ports. You can argue with me, Mr. Vishnu, why can't we have one switch of 48 port? We can definitely have that, right? But you have already purchased the 24 port switch. Why do you want to buy another 48? You do not have that requirement. But yes, I do agree with you that tomorrow the number of user could be reaching 100. Then I would say just buy more switches, because at the end of the day, you need to connect everybody to your network, right? And that is why it is going to dependent on your number of users or number of employees, right? That how many switches are you going to have in your enterprise or your organization or your startup, right? But now let's concentrate on now's problem. The problem is that we are going to have 40 different employees, right? 20 out of them is part of marketing, 20 out of them are part of engineering. It is as simple as that, right? You have bought another switch, which is switch 2, and now you have created another VLANs, right? The same VLANs. VLAN 10 here and VLAN 20 here. Believe me, you can have the same because VLANs are exactly same. So this VLAN 10, actually what you are going to do is, here you will be giving IP addresses from 192.168.10.0/24, because at the end, your VLAN 10 is one network, only one network, which you have decided to give IP address from 192.168.10.0/24. It is as simple as that. Doesn't matter whether it is 5 switches away from you. Similarly, here also, that you are going to give IP address from 192.168.20.0/24, because VLAN 20 is corresponding to 192.168.20.0. In yesterday class, I have mentioned that the VLAN and the network is analogous to each other. There is a one-to-one mapping, right? So it means that we can have here 10.40, 10.50, 10.60, or whatever the IP addressing range you want to decide on, right? Here I'm going to have 20.40, right? 20.50, and then 20.60. It is as simple as that, right? But here is my problem. I know that when I define these interfaces, I have to specifically says that these interfaces may be 0/1, 0/2, 0/3. These are part of my VLAN number 10, right? Again here, maybe 0/4, 5, and 6. These are part of my VLAN number 20. Similarly, I need to say that here, maybe whatever the ports you are giving, you have decided, doesn't matter, it is 0/1, 2, 3. Maybe it is 4, 5, 6, right? These all should be part of VLAN or access VLAN 20, right? Here, access VLAN 20, access VLAN 20. Sorry for that. This is actually access VLAN 10, 10, 10, and this is also 20. This is 20, and this is 20. You know, right? We all know about it. If these are different switches, we can do this. But here is my question. Suppose VLAN 10 wants to communicate to VLAN 10 here. It means that there must be some link between these switches. Maybe suppose this is my port number 24, and this is my port number 0/23, right? The last two ports of this switch. Similarly, here also 0/24, 0/23. So I am connecting two different ports of the switch, right? This green interface I am going to assign to VLAN number 10, and here also to VLAN number 10. It is going to forward the traffic of VLAN 10. If I say traffic, I mean to say the frames of VLAN 10, right? If I have this yellow link here, it is going to forward the frames of yellow VLAN or VLAN 20. It means that I have to assign this port to VLAN 20. And because this port is part of two different switches, right? I need to say that you are maybe 0/23 on switch 2, you are part of VLAN 20, and same thing here also. But remember, on these AND hosts, right, on these computers, I am just connecting these cables directly into my RJ45. I do not say that you belong to which VLAN because computers does not need to know whatever the concept we are defining here. Those are for switches, right? Or those are for your network, not for the endpoint. An end user don't worry about it that which VLAN it is part of, right? It is the responsibility of the network engineer to configure all these VLANs, to segment them, that the VLAN 10 user in the marketing and VLAN 20 user into the engineering. It is as simple as that, right? So overall, if I say that we are giving two different interfaces, and I'm saying that these two interfaces are part of VLAN 10, right? So now let's see how the communication is going to happen between them. So suppose this VLAN 10 host.10 wants to communicate to 10.40 here, right? So what is going to be? Suppose it is having the MAC address A colon A colon A or A dot A dot A, right? And this is B dot B dot B, suppose, right? So what is going to happen? It is going to create this message where source MAC is going to be A, A, and destination is going to be B, B, B. It is as simple as that, right? It is going to reach on this switch. Sorry for this. So this is going to reach on this switch. And suppose if I say, let's talk about first message which goes out, you all know, which is going to be your broadcast message, F dot F dot F, right? So where this broadcast message will be going, you all know that we have created a VLAN 10. So switch knows that where it needs to send this broadcast frame. It is not going to send this broadcast frame to VLAN 20. Why? Because VLAN 20 is part of some different domain. It is going to forward this. So this frame is coming here. It is going, of course, towards dot 20. It is going, of course, toward dot 30. And here is the thing. Because you have configured this interface of the switch to be part of VLAN 10, right? That is why this frame is going to be going over this interface, right? And reaching to switch 2. And of course, on switch to this interface, you have configured VLAN 10. Switch 2 will understand that whatever the frame is coming, it is for VLAN 10 interface. Why? Because you have specified it. It means that whatever the frame is coming, it is going to go over this interface, and this interface, because these are also part of your VLAN 10. See what you have done. You have increased your domain, right? VLAN 10 previously was on switch 1, but you need more employees. Those need to be connected to switch 2. But now you have two different VLANs, VLAN 10 on switch 1, VLAN 10 on switch 2. If you need to connect them, then of course you are going to need a link between them. It is as simple as that. Similarly, if somebody from here wants to communicate to here, the traffic is going to go over like this. So I have shown you with the example of a broadcast frame, right? But it is going to be true for the unicast frame also. It is as simple as that. The switch learning, the CAM tables of the switches are going to be same, right? Now there are two CAM table. One is in switch 1, the other one is in switch 2, right? Switch 1 knows that basically, if I talk about A dot A dot A, then it knows that A dot A dot A is connected to 0/1 and B dot B dot B, which is here 10.40. For switch 1, it is connected to maybe whatever this interface is, maybe 0/24 interface. So it is connected to 0/24 interface. It is as simple as that. So this is going to be your MAC address table. and the working is going to be same, right? How switch 2 is going to learn about that host A or dot 10 is here, right? A colon A, because whenever it is going to receive the broadcast frame from here to here, switch learns it cam table on the basis of source MAC address, which is going to be A dot A dot A. It is received over slash 24. That is why it is going to learn it, right? It is as simple as this. Working of VLAN, working at layer 2, it is not changing at all, right? But what do you see here? If I have two VLANs configured on a switch, I would be needing these two links, right? The green link and yellow link. Green link is taking traffic of what? Green link is taking traffic of actually your VLAN 10, and yellow link is carrying traffic of your VLAN 20. We all know about it, right? But suppose if I need to create 25 VLANs, what is the use case? I am not sure right now because you are not able to understand it. But yes, suppose I need to create 25 VLANs in switch 1, and the same VLAN should be on switch 2 because I have employees in different VLANs, right? Don't you think this approach is going to be really, really waste? Why? Because now between two switches, I would need 25 links because I have 25 VLANs here. I have 25 VLANs here. I need 25 different links, right? One link is going to take care about VLAN 1, say maybe VLAN 10, 20, 30, 40, or whatever the VLANs you have defined here. 25 VLAN. One link for every VLAN, because if you have two switches, then it is a problem, right? It's a big problem because your 25 interfaces are going just connecting two switches. And suppose this is a 48-bit port, a 48 port switch. It means that out of 48, your 25 ports are just wasted, right? You have only 23 ports, right, to connect your uh, host. And this is what happening, right? And if that is the case, then basically this approach is not good. And again, we are talking about efficiency here. Although you can definitely have 25 ports to connect two switches, but those ports are just carrying the traffic of different VLANs. Can't we do something like this that maybe we have switch 1 here, maybe we have switch 2 here, and of course there are 25 VLANs here, but I connect only one single link between them, and this single link is carrying traffic of or the frames of multiple VLANs. Did you get the problem? Right? Previously, if I do not do like this, means see, I am thinking to improve this traffic. I am to improve this complete network, right? To more efficient. Previously, as you can see, there were 25 different ports I need to have if I have 25 different VLANs on two switches. Why? Because for every VLAN, I need to have this link so that it can carry traffic of that VLAN. It is as simple as that. But this is wasting my number of ports. This is wasting my cables. Why can't I do something like this that I connect only one wire between switch 1 and switch 2 and then call it a day? And I inform these switch 1 and switch 2 that something is coming. This link is not the normal link. This is not the normal access VLAN link. It is something else. The normal link can take traffic of only one VLAN, but this link, which we need, right? This link can carry traffic of multiple VLANs. But how it can carry traffic of multiple VLANs? This is going to be the discussion of next board. Here you go. So I have removed the two links between the switch 1 and switch 2. Everybody, if you can see, this is switch 2. I have removed these two links, and now we have this single link. Although this is a little bit fat than the previous one, I just want to showcase you that you can connect only one link. Maybe this link is 0/24. And here is my problem. The problem is, what should I configure on this link? Shall I say that this link is for VLAN 10? If I say this link is for VLAN 10, then of course it is going to take the traffic of VLAN 10 only. It is as simple as that, right? Interesting. Then how it is going to take traffic of multiple VLANs, right? I do not want to configure it for VLAN 10. I want it to configure it for any number of VLANs which you have defined. Maybe you have defined VLANs 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Suppose. If that is the case, you have 10 VLANs you have defined here. I would have need 10 different links, but I want to send all the traffic of these VLANs over a single link. And what I will do, I will just think about it, right? Try to think about this problem. How I can do that? At the end of the day, I am sending frames. The VLANs is sending frame, right? Maybe if it is coming from A.A.A, it is going to B.B.B. At the end of the day, we are sending a frame, right? And of course, in this frame, we have the IP data, whatever it is. So I am not bothering to write it down, right? But you all know. What if I mark this frame with something, maybe the color coding or something, right? Maybe if I mark this frame with the yellow color or to the green color, right? If I say this is my green color packet, that is it. Instead of putting all the intelligent into this link by configuring them, I am putting intelligent into this frame. That frame is going to inform the other switch, hey, I am from VLAN 10. I am from VLAN 20. Maybe this frame is putting this number here that I am from VLAN 10. Suppose if that is the case, then what is going to happen? Whatever the green packets you are seeing here, these are for VLAN number 10. And somebody, the switch one, before placing these two green packets, right? Before placing these two green packets over this link 0/24, it is saying that this is for VLAN 10. It has hard coded this value. And who has done that? Host doesn't have any idea about VLAN, so no doubt about it. We do not have to configure anything. They are just sending the plain IP packet, which is encapsulated in the Ethernet frame, where A.A. is the source address, B.B.B is the destination address. You all know about it, right? Source does not have any information about it. But yes, when it receives here, you all know 0/1 port belongs to VLAN 10. Switch knows that if it wants to reach to VLAN 10, it needs to send it to other switch, and the switch which is connecting between two other switch is having a special link. And before sending the packets or the frame over this link, the switch does an intelligent thing, that it is marking these packets with VLAN 10. Similarly, it is marking the packet of the yellow VLAN with VLAN tag 20. We call them marking this packet, or basically we call them tagging, right? Because we are literally putting a tag on this frame, that Mr. Yellow frame, you are yellow, or basically this frame is going to have tag value of 20, so that when these frames reaches here at switch 2 is pretty sure about it, right? That VLAN 20 or whatever the yellow messages or frame it is coming, it is going to open it. It will see, array, that's basically it's for VLAN 20. And if this is for VLAN 20, it is going to forward this frame inside this VLAN 20 and not to VLAN 10. It is as simple as that. Doesn't matter if this is an ARP request also, means if it is a broadcast frame also, the switch is going to learn that Doesn't matter if it is an ARP request also. It's a broadcast frame. I'm not going to forward it in all of my VLANs, all of my 10 VLANs. What I'm going to do, I'm going to read this frame and I will come to know about that this frame is for VLAN 20. I'm going to forward it to all the ports of VLAN 20 if it is a broadcast frame. If it is a unicast frame coming going towards this B.B.B, then I will be forwarding over it here. It is as simple as that. This is how two computers are going to communicate with the use of this superb concept called trunking. And again, as I mentioned again and again, right, whatever we used to learn with respect to TCP/IP, right, especially specifically in IP layer and specifically in data link layer, whatever we have discussed, those traffic flows when the host is inside the same network, when the host is in different network, if you understand that, what we are going to do along with the study of CCNA now is we are just improvising, we are just including the efficiency, right? The base has been built. What we are doing, whatever we are doing, it could be wrong. It could be a wrong way, because see, there is no doubt about it that you can buy a huge switch, maybe of 128 ports, right? Huge switch, and you can say that, okay, if I have 10 VLANs, I can have 10 links between them. But this is not an efficient way. So people are doing some efficient things here. Over one single link, you can send traffic of multiple VLANs. It is as simple as that. But do you think that even if you do this way, VLAN 10, maybe you have host Z in VLAN 10, which wants to communicate to host X in VLAN 20. Can you do that? No. Still, VLAN 10 traffic can be forwarded towards VLAN 10. VLAN 20 traffic can be forwarded towards VLAN 20, right? No host of these VLANs can communicate with each other. And the reason is because these are two totally different networks. It is as simple as that, right? And if we have two totally different networks, then connecting this green network, whatever we have from here to here, this is going to be my green network, right? And from here to here, this is going to be my yellow network. If I want to make them connect, so these are to my different network. The upper network is going to be 192.168.10.0/24. The below network is 192.168.20.0/24 network. And if you need to connect these two network, you all know for the fact that you need to connect them with a router, right? Router is going to have one address in this network, and mostly that is going to be the first address, which is 192.168.10.1. And here also it is going to have 192.168.20.1, the first IP address /24. And now this router knows that I am connecting to two different networks. Doesn't matter how this network is built, whether these are VLAN based or the normal network, one switch, seven switches, 10 switches, who cares, right? But if you need to communicate between this guy, VLAN 10, and VLAN 20, you need to go in this manner. If I showcase you with this color, basically you need to first come out to this router, and then basically you need to go out to other VLAN, right? How this is going to happen, do not worry about it. We will be talking about it, right? But I want to give you the clear big picture that if we are using trunk also between two switches, it doesn't mean that two different VLANs can communicate over this trunk. Trunk is to carry traffic of multiple VLANs or the frames of multiple VLANs. So if I say traffic, the meaning is the same, right? We are exchanging the packets. So do not worry about the terminology sometimes. If I say traffic, it is also meaning frame, right? Very, very interesting. Now, as I could see that there are some questions that Mr. Punish is answering also, but I would like to take a pause. It's half an hour already, right? So basically somebody is asked, Harshit is asking difference between subnets and VLANs. So subnetwork is basically something which is actually your layer 3 concept, because we are talking about IP addressing there, right? And layer 2 is your VLANs where we are talking about, right? So at the end of the day, what are you doing with the L2, right? Right? Or the VLANs, you are just dividing this network into multiple pieces, right? You can give them different network or subnetwork number. For example, if you create, this is a very, very good question, and the confusion should be there in everybody's mind, right? Suppose I had this big network, 192.168.10.0/24, and if I want to break in this into 4 networks, what I can do is I can have 192.168.10.0/26. Why 26? You should know by now. Then the other one is 192.168.10.64/26. Then another one is 128.24. This is 26. This is again 26. And you know the last one is dot 192/26. These are the 4 networks. Everybody is having 64, right? So previously, suppose your company is assigned with this IP address, and now your company is having 4 different branches, right? Not branches, 4 different streams: HR, sales, marketing, and engineering. Suppose you want to have these people sitting over these over different switches. Maybe you are connecting switches like this, right? Some people of HR here, marketing here, engineering here, right? Sales here, similarly here also. So basically what you are doing actually, you are creating different network which are spanning across these multiple. So basically if I have HR here and HR here, what you are going to do, you are actually creating this HR network. And suppose these can not be more than 64. So you can give this yellow network is basically, this is my logical network out of it, right? Physically they have, right, means connected over switch 1, switch 2, switch 3. Just try to visualize it, right? But at the end of the day, this network, suppose I have decided 192.168.10.0/26 network to give this HR. And then similarly, second is the marketing folks which are here, which is here. So basically there is another network which you are creating. Let me choose the another pen here, right? This is the another network of the marketing folks, and you have giving it 192.168, maybe 10.64/26. Similarly, the another network, the other network, 4 networks. At the end of the day, what you are doing, you are actually having different networks. And a network is analogous to a VLAN, right? Because at the end of the day, what is VLAN? VLAN is the set of hosts such that if a particular host sends a broadcast message, it will be received to host in the same set. It is as simple as that. Now somebody is asking, can we have multiple L2 partition VLANs on the same L3 subnet? That is what we have done here, right? Because the subnet definition is very, very interesting. If I say this was your network and this is your subnet, that is perfectly fine. But if you divide it, this is going to be your network and the other one, whatever are coming, are going to be your subnetworks, right? So to me, if I'm a bigger network, then I can say that these are my subnetworks. But if I go into a particular subnetwork and if I divide them again, then I will become the network again. It is as simple as that. Do not get confused. But thank you so much for asking your question. And he's saying, Hyponish, it is possible to connect different networks on a switch. It depends on the switch, right? Whatever we are talking about, these are pure layer 2 switch, right? Pure layer 2 switch does not understand, they do not understand, right? IP layer at all. And if they do not understand the IP packets, then how they are going to forward the IP packets, right? But yes, we are bringing some intelligence into these L2 switches to make them L3 also. And probably you can see when you learn more about it. Okay. Having said that, now let's talk about, I think everybody get the concept of trunk, right? If you can give me a hand raise, it is going to increase my confidence that yes, you got it. I could see that there are some hand raises. Perfect. That is very, very good. But still, people are not participating, right? There are many people who are still haven't raised their hand. For example, okay, okay, I could see many of them. Okay. But whoever have not raised the hand, and if you are not getting anything out of it, please do ask. Otherwise, there is no point of sitting here. Having said that, let's talk about one more concept, that how this labeling or the tagging thing which we were talking about is working. Okay. So what we were doing here is that if it is a VLAN 10 packet, right? So suppose it's a green packet which is coming out. What we are doing here, this was the frame actually, right? And I am saying that we need to mark this frame with the VLAN 10 so that when it reaches here, switch 1 understand this is for VLAN 10 and it is going to forward it here, right? Suppose something is coming for the yellow VLAN, we should be marking it VLAN 20 so that it can reach here and forward it here. It is as simple as that. So what we are doing is, you know that we have this frame. I have deliberately removed preamble plus SFD, right? But presume preamble and SFD was here. We have destination MAC, we have source MAC, although destination should be here, source should be here. Then we have type field, we have data field, we have frame check sequence. And here is the green thing which was not there when we were discussing frame. So basically, there is a standard known as 802.1q. Simply, we can call it as .1q also, right? Which says, and this is, guys, the same thing, right? If we see our post office analogy, then there I was talking about the documentation, right? People can read the documentation and then can start doing their work. These are the set of rules. So 802.1q have defined the rules of this tagging. Interesting, right? They are saying that there is a 4-byte field I am going to include in this frame itself. So previously, the frame is going to be increased by 4 byte because of this requirement, right? Otherwise, we need to use 12, 13, 15, 25 cables to connect two different switches. Interesting, right? We do not want to do that. And that is why .1q tagging is coming into picture. This is the standard. This is the set of rules which says I'm going to put 4 byte of header, 4 byte of this information. Out of this 4 byte of information, 12 bits are reserved for VLAN ID. With 12 bits, 2 to the power 12, you can create approximately 4096 numbers. Because 2 to the power 12, if you calculate it, is going to be 4096. Doesn't matter how many VLANs you are having here, 4096 number should be more than enough, right? And that number is actually sandwiched inside this complete frame. So we are just putting this tag value into your frame. And we are making aware this switch 1 and switch 2. That switch 2, whenever somebody has configured this as a special port, and by the way, guys, this is a special port which can carry traffic of multiple VLANs. is known as a trunk port. Previously, whatever the ports we were seeing here, those all were the access ports, right? Trunk access port can take traffic of only one VLAN. And that is why we used to have 25 links between the switches if we have 25 VLANs. But trunk can take traffic of multiple VLANs. It is as simple as that. So through .1 queue tagging, which is a standard, we can define a 4-byte field which we can insert a 4-byte field into the frame. Out of these 4 byte, the 12-bit is used for VLAN ID. That is what you have seen here. If this switch placed this .1 queue tag, so you have a packet you have placed inside this packet or the frame that the tag value is 20. When this reaches here, switch 2 knows the rules. It is going to see that this is a trunk port. And over the trunk port, whatever I get, I'm getting something with a tag, right? And if I'm getting something with a tag, then that tag is actually specifying me the value of VLAN where I should forward this frame to. So once this sys packet is reached, switches 2 is pretty sure that I know the domain of this frame. I know the boundaries of this frame. This frame cannot go out of the VLAN 20. I need to find wherever it goes, want to go here, and I want to see in the VLAN 20. Interesting, right? And that is where I am introducing one more concept here. So when we were talking about switch CAM table, we were talking about the MAC address. We were talking about the interfaces. Like, for example, you must have seen that if this is 0/1 interface and the MAC address is A.A.A, very, very important concept, everybody. So this A.A.A is connected to your 0/1 port. But also, you know for the fact that there was third column too, and I was saying that I do not want to introduce it, right? Why? Because you could not able to understand it. Now I am going to introduce it. Basically, this is your VLAN number. So these things are part of VLAN 10. B.B.B is part of VLAN 10. If this is B.B.B, maybe there is Z.Z.Z. If that is the case, then that is part of VLAN 20, Z.Z.Z, right? Maybe it is connecting to 0/6 port. It is as simple as that. This is 0/2 port. So basically, when switch 2 receives this, or when switch 1 receives any packet or the frame, right? It is going to check first thing first whether there is a tag value of on it or not. If there is a tag value, then switch 1 is only going to check in VLAN 10, not in VLAN 20. It is as simple as that. Why? Because this frame was for VLAN 10, then it is going to check only the entries where VLAN 10 is written. So this is going to be the first check, and after that, this is going to forward the packet inside this VLAN 10. It is as simple as that. So the CAM table or the MAC address of the switch is going to have 3 different columns. One is VLAN, then MAC address, and the interface. It is as simple as that. Interesting, right? Having said that, now let's talk about one more interesting concept. And now suppose I say that I have a host connected here, suppose, right? And I have given it as a value. So this was my 10, this was my 10. Sorry, I made it 1, right? And I have not configured anything on this interface. So by default, guys, if I say, if you come up with a switch and you start connecting your host to it, you all know that these hosts starts communicating with each other, right? If it is A, B, C, D, if you connect them with a switch, right, they are going to start communicating with each other. But believe me, as you know, the switch cam table are going to having three entries: VLAN. Who is defining the VLAN for the initial host? What is the VLAN configuration here? Of course, if I have VLAN 10, I will be marking this access VLAN 10, 10, 10, no problems at all. But when you freshly take the switch, right, and you connect all these hosts to it, to what VLAN these hosts are part of? This is very, very interesting, right? So by default, switch comes with one VLAN, which is known as VLAN number one. And you do not need to configure, because by default, whatever the port you have on the switch are part of VLAN 1. And that is why everybody was able to communicate. But suppose if switch comes with the default configuration that the starting two ports are in VLAN 10, the other ports are in VLAN 20, and if you connect ABCD to them, they will not be able to communicate. Means A can communicate to B, C cannot communicate to D. Why? Because if you have this default configuration, this is part of VLAN 20, this is part of VLAN 10, it is going to cause a problem. So what is going to happen? In all the switches, all the ports comes with the default VLAN, which is your VLAN 1. All the ports are part of VLAN 1. It is as simple as that. Right? And hence, they do not want to break this. So what is going to happen? Suppose I have a switch host A here. I have a host B here, which are part of my VLAN 1, and the VLAN 1 IP address maybe say 192.168, say this is 100.10, and this is 192.168.100.20. You haven't specified any VLAN here, right? By default, switch 1 and switch 2 place this in VLAN 1. They are going to place them in VLAN 1. It is as simple as that, right? And then there is a trunk link. Trunk link can send traffic of multiple VLANs. But believe me, whatever is your default VLAN, right? When it sends packet over this guy, it just simply sends the frame. If it is coming from VLAN 10, of course it need to write down VLAN 10. If it is coming from VLAN 20, of course it need to write down the VLAN 20. But at the end of the day, whatever the .1 queue have specified, this was specified with some particular rules. And there is one rule which says, and I will tell you the reason, I will tell you the why behind it. Do not worry about it. Suppose this is one frame which is coming out of the switch which is untagged. The meaning is there was no .1 tag, right? This is the normal frame which is coming out, maybe the red color here, which is coming out from this host. This is the normal frame without any .1 tag, .1 queue tag. If that is the case, and it is running, it is going over the trunk interface and reaching here at the switch 1 or switch 2, sorry, right? And there is no .1 tag. How would this switch knows where to forward it? Interesting, right? It is absolutely okay. There is no confusion, no doubt about it, that if we put .1 queue .1 queue tag on all these frames, so that when it receives at switch 2, it's going to open the .1 queue tag value. It will see that it is for VLAN 10, it is for VLAN 20, and accordingly it will be forwarding it. It is as simple as that. But what if we are sending a frame which is not having any tag value? And you must be thinking that, why, Mr. Vishnu? Why don't you tag it with 1, right? Suppose I do not want to do that. If there is a frame on this trunk port which is not tagged, where it is going to be go over the receiving switch side, and that is where native VLAN come into picture. The concept of native. If you do not know where to send the packet, send it to native VLAN. That is where, right? So over these two switches, I need to define that the native VLAN of this switch is 1. Here also I need to define native VLAN of the switch is 1. And if you define that, basically switch just send the packet as it is from these native VLANs. So if something is coming out of this host A, means the frame is coming out of it, the frame is not being tagged over the trunk, and these two guys have proper understanding that if we get a frame which is not tagged over the trunk interface, we will be sending it over to a native VLAN. And now here the native VLAN is VLAN number 1 because I have defined this is my VLAN 1, this is my VLAN 1. If that is the case, everything can start just working without any doubt, without any problem. So by default, VLAN 1 is default there, and VLAN 1 is also your native VLAN. If you do not define anything on this trunk interface, VLAN 1 is going to be your default, but it should not be the case. You can define any VLAN as the native VLAN. So for example, if you want to have VLAN number 60, and if you do not want to tag these packets, right? So it's defined native VLAN as 60 here, native VLAN as 60 here, but these native VLANs should match across the switch's trunk interface. Why? Because they should have the common understanding that if the packet is coming from the VLAN 60 here, it should go to VLAN 60 here, but you are not tagging them. There should be the implicit understanding, right? And that understanding is that if switch is having a VLAN, native VLAN, then it is going to forward all the frames which are not tagged into this native VLAN. It is as simple as that. So if I again repeat this process, if this host is sending a frame which is not tagged, which is received here, and if you have configured a native VLAN 60 here, so this is a common understanding of switch 1 and switch 2, right? That is going to forward this into 60, VLAN number 60. It is as simple as that. If you do not do that, VLAN number 1 is going to be your default VLAN. It is as simple as that. So the frames of native VLANs are not tagged, right? Any doubt? Any questions on it? If you have, please do ask. Interesting, right? So here I am deliberately leaving the concept of how these VLANs, whatever we have created on a particular switch. Suppose I have only one switch and I have created multiple VLANs, means two VLANs. One is here and another is here. Sorry for this, it should be with the color. And here we have some host, right? These are some hosts, and here we have some host. We all know green host can talk to green, red host can talk to red, but how to make them communicate, right? So there are two options. Either include some intelligent into this switch so that it can understand L2 plus L3. L3 means IP addressing, or connect this switch with the router, right? Connect this switch with the router. So the traffic, so of course, the .1, the default gateway for this VLAN is going to be this one, this router R1, and the default gateway for this one is this one, right? .1. I'm presuming you should have this understanding that basically I am having 192.168.10.0/24 network for this VLAN, 192.168.10.0/20.0/24 network for this VLAN. Here I am going to have .1 means 10.1. Here .1 means 20.1, right? So you all know that if this host is going to initiate a packet towards 192.168.20.20, suppose the host is here .20, what is going to happen? It is going to do an ARP. ARP for what? Not for inside its host. It is going to do an ARP for the default gateway because now it knows the communication is happening between network. If that is the case, your ARP is going to be here first, R1, right? and your packet should be going like here to here, and the R1 knows that, okay, I have a connected interface in 20, so it will be sending it to here, right? The packet is going towards R1 over this green link, which is the VLAN 10 link, and then coming over this red link, which is the VLAN 20 link over the switch. Believe me, guys, the router doesn't understand VLAN, so they do not need to configure. So basically, you are having configured here, it's a VLAN 10, here is a VLAN 20, so that switch understand when the packet comes, okay, this is for VLAN 20, and this is for VLAN 10. It is as simple as that, right? So if you want to make these two VLANs communicate, you need to introduce a layer 3 device which can understand the IP addresses, right? Interesting. But again, my same problem is that if I have 20 VLANs over a switch, then I would need these 20 connection. No, you can have this as a trunk also, which we are going to talk about, and we call this as a router on a stick configuration. Punish will be showcasing you in Punish or Dhaval will be showcasing you this router on a stick configuration somewhere. If you get it, perfectly fine. If you don't, that is absolutely okay. I'm confused in how the CAM table entries are filled in case of VLANs. From the start, step by step, can you explain? Okay, definitely we can do that. So Mr. Rachit Puri's question is, and thank you so much for asking these questions. Whatever is coming to your mind, please do ask. Okay. So Rachit Puri ji is asking that I am confused how the CAM table entries are filled in case of VLANs from the start. In case of VLANs, right? So suppose we have this switch, right? And I have two VLANs over it. This is my green VLAN, which is anything, right? And I have a particular host, two hosts in it, which are connected to two different port of this switch. This is A, this is B. The IP address of this one is, sorry, the MAC address is A.A.A, and the MAC address here is B.B.B, right? Similarly, I have here another VLAN which is having C, MAC address is CCC, and D, MAC address is DDD, right? This is connected to maybe 0/3 port, this is 0/4 port, this is 0/3 port, this is 0/4 port, sorry. This is 0/1, this is 0/2, right? I'm not sure where you get confused. I'm exactly telling you the complete process, right? And if everybody missed that portion, how switch is going to create this CAM table, let's see that, right? So at the first place, switch doesn't have anything, right? Whatever the table it has, it does not contain anything when the switch is booted, right? So I'm making three entries. One is for the VLAN, the other one is for the interface, and this is for the MAC addresses, suppose. But switch is pretty intelligent that whatever is going over its interfaces, right? It will start learning from them. So as I mentioned that 0/1 and 0/2 ports are part of your green VLAN, right? I would say it's VLAN 10, this is VLAN 20. If I say green, it is 10. And then 0/3 and 0/4 ports are part of your red VLAN, which is VLAN number 20. It is as simple as that, right? What is going to happen if A wants to communicate to B? First thing first, it is sending a ping packet. Suppose, right? Ping packet cannot be completed because it doesn't have the destination MAC address, and that is why A is going to send that ARP message. You all know about it. And what is the domain of that ARP? If you have only two interfaces in VLAN 10, it is going to be go over the 0/1, the ARP message, and whatever the interface were a part of the green VLAN, it should be forwarded to here. It should not be forwarded to the red VLAN. You all know, and that is why we are creating VLAN 4. It is the first step, right? This ARP message is going to have source of A, A, destination of F, 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 which is reading on 0/1 port. 0/1 port you have configured of this switch as the VLAN 10. It is as simple as that. So switch is going to say this is coming on my VLAN 10. The interface is 0/1 and the MAC address connected to it is A.A.A. If it is talking to B.B, suppose B.B is going to send a unicast ARP reply. Again, it is going to be VLAN number 10, 0/2 and B.B.B. We have talked about it. I am just including VLAN number, whatever you have configured here, right here on the interfaces because you have configured them, right? Similarly, in case of it is going to learn from the ARP, from the initial communication. It is going to say that VLAN 20 is having 0/3 interface because I have received an ARP from C.C.C. And similarly, D.D.D. It is as simple as that, 0/4, 20 VLAN. The whole sole point is that if the packet is coming, suppose this is my trunk link, suppose this is my trunk link. If a packet is coming, it is specifically written that the packet is for VLAN 20. Suppose it wants to go to D.D.D, the destination. Source, maybe, I'm not sure from where it is coming. Say E.E.E. When it receives on this port, right, switch is going to learn, okay, this is coming over the trunk port, and I would expect a packet to be trunk, and if it is not, sorry, I would expect a frame to be tagged. If it is not, then I'm going to forward it to the native VLAN. There is no native VLAN configured, and now suppose I have VLAN 20 here. I will be forwarding it over the VLAN 20 by seeing only VLAN 20 entries, right? Because this message D.D.D, I am expecting the source is saying that this should be part of VLAN 20, D.D.D. Even suppose this is okay, leave that case for now. But first thing first, it is going to check that VLAN 20 is here. So sorry, this packet is for tag 20. Tag 20 means VLAN 20, and I am going to see only the entries in the CAM table which are having this VLAN 20. It is as simple as that, right? And fortunately, we get it here. And suppose this way the communication is going to happen. Suppose this is not here. This D is here with the MAC address D.D.D. And suppose it is also sending the MAC, but it is also sending the ARP address. The entry is going to be 10, that it is connected to maybe 0/7, D.D.D. This entry is not there. Suppose in a hypothetical case, I move this from here to here. The packet is coming for again D.D.D, right? The packet is for VLAN 20. Even this switch is not bother to look the entries of .10. The packet is going to be considered as a case that this switch is not going to understand which VLAN we need to forward it, right? It is saying that it is for VLAN 20. In VLAN 20, it is going to say that I do not see it. This will become the case of unknown unicast because you need to see only in VLAN 20. That is it. That is why you have created VLANs for. And in case of unknown unicast, there is going to be broadcast. So this packet is going to be broadcasted here. As simple as that. Mr. Rachit, did you get it now? I would expect.
Yeah, Vishnu, I got it.
Perfect.
Just another thing, like how does the source know that what tag to give, like in the tagging
Again,
we
I'm
have
saying,
given 20.
source does not need to know. Source is just your, again, I'm saying switch one. Just try to understand switch two. And guys, I would say these are the questions which should come into your mind, right? If they are not coming into your mind, you are not curious enough. And as I mentioned, the only pre-requirement for this course is to be curious, right? So if we have switch one, if we have switch two right here, right? The question is how this host comes to know that I need to send it this tag, right? It should not be, right? You have configured this host at the first place. Suppose this was a part of your marketing one. You have configured that this 0/1 port is part of 10. Where you have configured, Punish is going to showcase you that you configured all the VLAN related things on this switch. And then basically this trunk. Right now, the packet is sent by this host, maybe this frame. Only frame comes out from the host. It doesn't know which VLAN it parts of, right? It doesn't have to. It doesn't need to put that tag also. But when this frame reaches here, this switch knows, okay, this host is part of my VLAN number 10. Do you agree, Rachit, that this switch knows that this is part of my VLAN 10?
Yeah, Vishnu.
Now it is going to forward over this trunk, and the trunk rule says that whatever the frame you are going to forward me over, you need to tell me for which VLAN is this. And you are specifying right here that this is for VLAN number 10. So that when this guy comes to know, okay, this frame is for VLAN number 10, I will be forwarding it signed VLAN number 10. It is okay? Did you get it?
Yeah, got it. Yeah.
Perfect. And I'm again thinking that most of you must be having doubt, and that is why we are recording these videos. Believe me, if you want to make anything into the networking, these are the fundamentals which you learn, right? This is the time you are getting, right? Specifically dedicated, maybe 1 month, 2 months, 3 months, I'm not sure. You are getting time for dedicated, means you have been paid to literally learning, right? Use this opportunity, because in coming time it is going to be that you might get busy with a lot of things, with the personal life, with the corporate life, so many things. This is the time to learn, right? And you must be thinking that again one teacher which is saying us to read, right? When we were in 8th standard, everybody was saying that 10th is the way, right? 10th is going to decide your future. Read. Okay. Then when you were in 11th, everybody is saying 11th, 12th is everything, right? You will get admission into the engineering. You spend 4 years in engineering, right? Then you get a job. Now again, somebody is saying read in the job. I'm not saying you spend day and night into this. Few hours, maybe 1 hour, half an hour a day, it is going to change, right? But how many of you says that in the 4 years of engineering, you all the times you were reading or studying? No, right? Engineering was one of the most important days of our life, right? You all know for that fact. I'm just saying half an hour, 1 hour is going to be more than enough. Just read something new, just read this thing, right? It is going to help you. Otherwise, it is going to be a problem for you. Just a piece of advice. Unsolicited advice, but it's an advice. Having said that, what is saying, do all the port of one switch are dedicated to one VLAN? By default, it is, Mr. Vedant Goswami. By default, if you say all the port of a switch, all the ports of this switch are part of the VLAN 1, which is the default VLAN, and that is why when you attach somebody to it, everybody start talking, right? But you can divide them into different VLANs, because you know the reason. If you go behind, you can do all the you can just read, you can just see this video to understand the VLAN concept more. Because right now the problem is we are forgetting for what exactly we have built this VLANs for, right? We do not want that ARP message to be go everywhere. We do not want Anjali to go in every network of this world to know where Rahul is. We do not want that, right? This approach is not working. And that is where the ether, guys, everything is connected. You need to think from the first video towards it, right? Interesting. By now, we are into the 6th session. Till we have just covered only 40% of the CCNA, and that is in that some portion from one section, some portion for other sections, right? But the aim is not to complete each and every topic of CCNA, right? The aim is to build your basics strong, so that whatever is coming means you can go and read about the concept. If you're reading them, it should make sense to you. These are the things which are missing in most of the courses, right? Having said that, let's talk about the new board. If you have any other question, please do ask me. right? But I am impressed with the question and thank you so much, right? So this is the last topic when we go uh, before the break. And then once we come back from the break, I'll take another half an hour, right? And then Punish is going to guide you with some of the concepts of the VLANs, how basically we are going to configure it, right? So what is happening here when you assigned a cube, okay, uh, generally what happened previously, when you join a company, you were given a cube, right? Inside this cube, you have one computer like this, right? And then basically you have one phone also, which is the Cisco phone, right? And then basically you sit here and work on your computer and with the phone. There is, but nowadays basically everything was connected over the wired previously, but now you can see wireless. And we are going to have a short session, maybe an half an hour session with the wireless engineer also, because I'm pretty bad with respect to wireless. I'm reading some of the things about wireless, but now still I do not think that I'm pretty good with it. So we will be inviting somebody from the wireless team to give you a little bit insight about the wireless network too, right? So consider everything is wired. So at the end of the day, what is going to happen? This PC or whatever you have should go to this switch, right? Because if this is your cube and you are Mr. A, there must be somebody in other cube, and if you want to communicate with each other, then that person also need to be connected with the switch, right? You are employees, you are part of this thing, right? And believe me, I am going to give you the clear picture of how an enterprise network work, right? But for now, we are just learning something in the pieces, right? And if I remind you, then basically we have divided the complete problem of networking into 5 pieces, like application layer, network layer, right? We are talking about only layer 2 now. From tomorrow, we will be starting layer 3. Okay. So here is my computer, here is my phone, right? And everybody is sending data to the switch. So basically what is happening, I take a cable from my uh, PC, I connect it to this phone, and then you must be thinking that how come you connect a cable into the phone? If you see, means if you are in campus right now, just see any phone of Cisco and just see behind it, there are going to be a 4 ports or 2, 3 ports available for this RJ45 connection. So basically, this is not a normal phone. This is your IP phone. At the end of the day, whatever you speak, it is converted into packets and going over the Cisco's network and then outside somewhere, right? So you connect and then another cable you connect from here to here, right? Interesting. And over the same cable, you are sending your data and your IP phone is sending the voice. You can argue with me, Mr. Vishnu, is there is a difference between data and voice? No. In terms of whatever is coming out, everything is 1010, right? But yes, there is not difference between data and the voice packets, but how voice should be treated is different than data. Why? Because it is a voice, it is going to get the more preference than data. Because if you are speaking to somebody and your packets of the voice packets are getting delayed, then you are not going to get the good voice quality, right? If both of you are talking, right, in different cubes, maybe you are in building 11, somebody else is building 16, they are talking with each other, right? And if we are not giving these voice packets as a separate treatment, then it is going to be a problem, right? So generally what we do in our switches, we create 2 different VLAN. One is for data and the other one is for voice. right? And interestingly, here, if I showcase you the same picture here, right? So what I'm having here is we have this PC, and this is entire. This one is your cube, guys. If you can understand, right? This is your cube. So let me remove this. So this is your PCA right here. This is your interface, RJ45 cable, which is going inside to the switch. Not the switch, this is IP phone. If you go and see, check behind it, it is going to be your a 4-port switch, right? The second you can go from here to here. It is as simple as that, right? And now, basically, you are receiving traffic from this switch, sorry, from this PC. You are getting traffic from this IP. So basically, Cisco's switches are intelligent to understand that something is coming from the phone and something is coming from the from whatever we known as this PC, right? So what you can say that this FA0/1, I have defined two VLANs over it. One VLAN is for my voice, which is VLAN number 20, and the other VLAN is for my uh, access VLAN, which is VLAN number 10. So I can say here that this port, whatever FA0/1, is going to receive traffic of two VLAN, VLAN number 10 and VLAN number 20. VLAN number 10 is the access and VLAN number 20 is the voice, right? You must be thinking, why can't we make it a trunk? We could have, right? But without making any configuration on here on this switch, I can make sure my PC is working, my phone is working, and the phone is getting the different treatment, right? Because the phone packets are going to be in the VLAN 20. If the VLAN 20, I can define for VLAN 20, we are going to choose the faster path, or basically whatever the frames we are receiving on the VLAN 20, we can give more preference, right? How to give them more preference? It is altogether a different networking concept, which is known as quality of service, which we are not discussing. Okay, so this is what I wanted to cover before the break. But once, okay, extremely sorry, you need to spend some more time, right? Because I want to give you this complete scenario, right? As I mentioned, that we are going to just 5 more minutes or 10 more minutes, right? So what we are doing here is we have a design requirement from the customer, right? Let's take an example of Mr. Rachit, right? Rachit has joined Cisco. He's an intern here, and now he's facing the customer. And the first customer he meets is working on his VLAN design. Mr. Rachit is pretty sure about it. He's saying, I have learned the VLAN, right? I know nitty-gritties. I understand the native VLAN too. I understand .1q trunking, everything I know, right? Just tell me the requirement, right? So customer, maybe the customer ABC is saying that Mr. Rachit, I have a building, right? This is the building. And I have three different departments. One is maybe marketing, the other one is engineering, and the other one is maybe HR, right? Remember HR and Red Computers? You know about it. So ABC is the organization for which Mr. Rachit has been assigned that you need to consult to this guy. And this customer is asking, I have three different VLANs, right? First of all, this customer do not have any idea about VLANs. He's saying that I have these group of people, right? I want that their traffic should be separated. If somebody send an R from here, it should not go to here. Can you suggest me something? And by the way, these are going to be sitting in different floors also, right? Interesting. This is the only requirement. And sometimes when you go and meet some of the customers, specifically the customers which do not understand networking, they are going to give you the requirement in pretty basic form. what is their problem, what they are facing with. It is going to be you who is going to translate this basic things into technical details, right? Sometimes even you cannot talk to some of the customer into the technical details, right? Because they do not know. For example, if you're talking to a chief information officer of a company, right? Maybe they did not know or they forget about how VLAN works, right? You are not going to tell them that this is the access port, this is something. No, you should not, right? So from where you are collecting the requirement, it is very, very important. This customer was very genuine enough. He knows few things about networking, but most of them he doesn't know. Rachit has joined Cisco recently, but he knows VLAN. So he's saying, rest assured, Mr. ABC.com or company ABC, I will give it a try, right? Actually, he's saying, let me brainstorm over your requirement. I'll come back to you again, right? So here is Mr. Rachit thinking loudly, right? Here we have Mr. Rachit Puri, and Rachit is actually thinking about the requirements. He came to know that he needs, for example, if on a floor one, first floor, if he needs that there are three different people of three different departments, he is thinking that he is going to need three different VLANs configured on the switch. But here is my problem. There is another floor which is quite far away, maybe, right? If that is the case, right? If that is the case, if that is quite far away, then you are going to need another switch for the second floor, right? Another switch for the third floor. And if you want to make sure that these HR guys are talking, you need to make sure that these switches are going to talk with each other. So this switch is going to have three VLANs. This switch is going to have three VLANs. This switch is going to have three VLANs. The VLANs are going to be same, maybe 10, 20, 20, 30. This is VLAN 10 guy. This is VLAN 20. Maybe the green one is VLAN 30, whatever you choose, whatever the numbering with Mr. Rachit is thinking about. It is very, very simple, right? He is thinking this design in its mind, and now this is the physical thing where he is implementing this. Switch 3, switch 2, switch 1 are going to be interconnected. And because there are going to be traffic of multiple VLANs, Mr. Rachit Puri is suggesting that this link should be trunk and 802.1q trunk. Why? Because whenever switch 3 sends the data towards switch 2, maybe it wants to talk towards switch 1, right? First floor guys, we need to make sure that you are tagging it properly so that I can send it to a particular host inside that network, inside that VLAN. It is as simple as that. Everybody, I need a clear answer from you whether you get something out of this board or not. If this board is clear to you or not, please raise the hands. I want everybody to be part of it. And if you are not raising your hand, then basically maybe I will be coming to you and asking questions. Okay. Okay, let's talk with Mr. Raghav, right? For 2 minutes, we have 2 minutes. Mr. Raghav Bharadwaj, can you hear me? Just unmute yourself, Mr. Raghav. Mr. Raghav Bharadwaj, can you hear me? This is not good, guys. That is, if you're talking, then you're talking on mute. Okay, let's talk with Mr. Sparsh Jain. Sparsh, you there?
Yes, sir.
Yes, Sparsh. So, do you able to understand this board?
Yes, sir.
Okay. All is good? Means if you have slightest of issue problem, please do ask.
Sure, sir.
Okay. What about Minakshi? Meenakshi, can you hear me? Meenakshi R? Okay, interesting. If you're talking on a mute. Arya Dubey, can you hear me? And that is why you don't raise your hands. This is interesting. Arya, can you hear me? Arushi, Avnesh, anybody? Okay,
Am I audible?
Yes, yes, I can hear you.
okay. So do you have any doubt, any question on this board?
No, no.
All good?
Yes, sir. Yes, I mean, yes.
Perfect. Okay, so having said that, let's take a break of at least half an hour. Maybe we are meeting at 11:32 or 33 once again, right? Bye till then. Okay. So welcome back once again. As I mentioned that uh, this board was actually explaining you some of the practical things that you can now design the VLAN based network, right? So before moving further, I would like to tell you that how a typical enterprise network looks, right? Suppose there is a small enterprise, right? It is having only one campus, or maybe you can say it's just a startup, right? And then they have a pretty small office in a building, or maybe which is over just one floor, right? So what they are trying to do is they have bought two 24 port switches, right, for their network. This is switch 1 and this is switch 2. So as you can see, these are 24 ports. So and out of these 30 people, right, I would say that they have an HR department of 10 people approximately, then marketing, sales and marketing, right? And then they have what do we call this as maybe engineering department, one of the most important department, right? And they have created there are multiple hosts they have, right? And these hosts are actually connected to these switches. You must be wondering that nowadays nobody is going to use these cables. I am with you on this. But at the end of the day, even your wireless traffic is actually flowing over this wired traffic, right? So between your laptop and switch, the actual switch, there is a device sitting there, right? Which is known as the access point, which is actually throwing the WLANs which you connect and then become the part of the network. But we are talking about here wired network. Wired network is the key. Maybe some guys are connected here, and that is how the 30 people are connected. So basically, we call these as the access switches, right? Very, very interesting, right? So this is kind of one building where all these people are sitting together. Now, maybe after some time, and that is where you are creating these VLANs over here, right? Three VLANs over this switch, one, two, three, right? And three VLANs over this switch. And of course, these are going to be your marketing, HR, and other VLANs. So this is kind of your building where everybody was sitting, right? So these switches are known as access switches, and the reason is because most of the guys are connecting here, right? Accessing your network. And of course, there should be a connectivity between these switches, and you know this connectivity should be a trunk, right? And now this company, what is deciding now, it is growing, and what you are doing here is you are actually buying some more space. Maybe there is another building where you have find some more space, right? And again, the three streams are going to be same: HR, sales, and marketing, and everything. So you have bought another one here, right? Or maybe another two switches here, where maybe now this company is of 60 odd people, And now we have another so many PCs here which are again connecting to the switches. So at the end of the day, this complete infrastructure of switches, right? Switch 1, switch 2, switch 3, switch 4, right? These are your access switches, right? Because people are connecting to it. And whatever you are making here, of course, the VLANs should be here also, those 3 VLANs, right? And now these 2 buildings, you need to make sure that these 2 buildings are talking, right? One way is to simply connect these switches to these switches so that they can talk. Or another intelligent way is that basically you have one more switch and you connect these switches like this, right? Interesting. So basically this is generally known as distribution switch, and the reason is because it is distributing the traffic between 2 buildings. This is your building 1 and this is your building 2. This was your access switches, this is the distribution switches, right? Interesting. Now I am not including the routing portion, but keep this picture in your mind, right? Because this is how you are going to develop a network for a customer. At the end of the day, this is your layer 2 network. Why we are calling this as the layer 2 network? Because nobody here understands IP address. Whatever the networking device you are seeing here, whether it's a distribution switch or whether it's an access switch, nobody understands but your IP addressing, right? But yes, these end host does understand because these can understand the complete TCP IP model. These end hosts know whether they are talking inside the same network or different network. When they want to communicate outside their network, they are going to send this to a default gateway, which we do not have, right? Right now, why? Because we are just learning piece by piece this information. Right now, we are on the layer 2. We are going back again to learn layer 3, right? Interesting. So we will be introducing another layer, which is called as a core layer. And if you can see that this is known as 3-tier architecture also in Cisco language. Why 3-tier? Number 1 is for access switching. The number 2 is for the distribution layer, distribute traffic between 2 buildings. And then there is going to be core layer, right? And because we are having 3 layer, this is known as 3-tier architecture of Cisco. But I agree with you that you do not have any idea about that how the why core layer is there. We will be introducing it. Do not worry. Most of the short companies are having only this 2-tier architecture, one distribution, one access, and the core is merged into this. But if you do not have any idea about the core, do not worry. We will come to this diagram again. We will complete this diagram again when we have a complete understanding of layer 2 plus layer 3. Because if you have layer 2, then you know Ethernet, you know switches, you know switching, right? If you understand layer 3, you know IP, Internet Protocol, you understand IP addressing, you understand routing. And if you combine L2 plus L3, it means that you know switching plus routing. Once you know switching plus routing, you can create a network based on that. That is going to be a route switch network. It is as simple as that, right? So just have this big picture in your mind where you are. But now if you can see that we can have multiple switches inside an organization, right? And those might be connected like this way, and which can lead to some of the serious problems in layer 2 network, which I would like to tell you. What is that problem? Okay, please pay close attention, because whatever the new technologies you are going to learn, whether it is software defined networking, open networking, right? Inside software defined networking, if you are becoming part of the data center team, you must be learning ACI, which is Cisco's software defined solution for data center. You might have heard about SDXS also, right? When you try to learn these new concepts, they will straight away say that we are actually solving a problem in the existing network, right? But most of us do not understand that problem, and that is why ACI and SDXs looks a little bit hard to understand. If you understand a problem, and you all are engineer, you all know this, if you get the problem right, maybe you can suggest some solution to it. But at the first place, if you do not get the problem right, if you do not understand the problem, it is going to be a problem. You cannot formulate a solution, right? You cannot give a solution if you do not understand a problem well, right? So here we are going to discuss a serious problem in the network, a layer 2 network, which these new technologies are also solving, right? So what is the problem there? I'm saying only not the new technology. There is another protocol which can solve this issue also, right? And again, the point of discussion is that now we are talking about increasing the efficiency of the system, because right now, whatever we have learned, right, VLAN, it is making the system more efficient by restricting the broadcast domain of address resolution packets, right? ARP messages. Now, what we are seeing here, the three switches are connected. Switch 1 is right here, switch 2 is right here, and we have this one is our switch 3, right? Sorry for the mistake, but we have three switches: switch 1, switch 2, and switch 3. It is as simple as that. And these are connected like this, that they are actually form, means switch 1 is connected to switch 2, switch 2 is connected to switch 3, switch 3 is again connected back to switch 1. It means that if you can see that there is a physical loop in the system, right? How? Switch 1 is connected to switch 2, switch 2 is connected to switch 3, and switch 3 is again back connected to switch 1. I just wanted to let you know that such kind of topologies can create a significant problem on the layer 2 network. What is the problem? The first thing first, you all know for the fact that suppose we have host A connected, which is having the MAC address A.A.A, and host B is having the MAC address B.B.B. Suppose, right? What is going to happen if this host A wants to communicate to host B? Suppose these are part of the same network. They cannot send the IP packet directly. So they take the help of address resolution protocol to let them know that what is the MAC address associated with B, and that is why this host is going to generate an ARP message. This ARP message is going to be broadcasted, right? And the destination MAC address is going to be f.f.f, means all Fs. And we all know that if this switch receives this ARP message from host A, this message is going to be broadcasted over this interface, 0/1 interface, and 0/2 interface. And suppose this interface is 0/3, suppose, right? I am going to say, and suppose everyone is in VLAN 1, so I will write, this is VLAN, everybody is in VLAN 1. We haven't created any VLAN, by default it is VLAN 1. And then basically we have MAC address and we have interfaces. So once this switch receives an ARP message over the switch 1 over 0/3 interface, switch will install a KM table entry right here, which says that the MAC address A.A.A is attached to 0/3 port. It is as simple as that. We have talked about it so much time, right? This frame is going to reach here, the ARP request, which is a broadcast. What switch 2 is going to do, switch 2 is going to forward it, right, on all the ports except the one on which it is received. Same thing here also. So the packet is going to be from here to here. And of course, 0/2 is also forwarding it from here to here. Interesting. Switch 2 is going to learn the same packet, same frame. Switch 3 is going to learn the same frame from switch 2. Oh, extremely sorry. Okay, let me correct the conversation, guys. So this is going to be a switch 3 all the times, and this is going to be switch 2. Okay. Switch 1 is going to be this one. This is going to be switch 2. This is going to be switch 3. This is final. So switch 3 will be sending a message, ARP message, the same message, which is having source address of A.A.A. It is also sending the same message A.A.A, right? And because this is the ARP message, what this switch is going to do, it is going to forward it on this interface, right? Whatever it is receiving over switch 3, and whatever it is receiving from here, it is going to forward it here. Interestingly, if I showcase the ARP message, it is going from here to here with the red pen, then it is broadcasted here, and it is coming back here, right? Do you think it is going to stop? No, absolutely not. Switch 2 or switch 1, whatever we have here, because it is the broadcast frame, it is going to go again here, right? Again, there is a loop formed in the system. And there is another loop formed with another piece of information, because this ARP message is going this way also, this way also, this way also. You can understand there is a loop of these ARP messages, right? Ethernet was in development in parallel with the IP addressing. In Ethernet frame, if you have seen, we do not have any mechanism which says that after so many rounds, this frame should be discarded. No, this frame is going to be looping there for an infinite amount of time. And what does a switch does? If we are getting a frame on the switch is going to check its scan table, and it is going to switch this packet as soon as possible. The switch role is to forward the packet as soon as possible, right? This is what it is going to do with all the frames. Whenever the R frame come, it is going to broadcast it everywhere. Whenever the R frame come, it is going to broadcast it. Don't you think that the switch CPU is going to deal with all the frames? And whenever it comes, it is going to forward it, right? And switch work is to forward this packet as quickly as possible. And we have seen in real production network that if such kind of a loop forms, the switch CPU goes to 100%. What is the meaning of CPU? The central processing unit of this switch cannot do any other work because it is busy in sending those ARP packet every time whenever it comes. Even this is 100%, right? Processor is not giving attention to anything else apart from sending these ARP messages, right? Even if you want to log in into this system, you cannot, because processor is not going to let you log in, because login is again a process through which you are going to take control of this router. It's a huge problem, right? And if such loops happens in customer environment, all the switches are going to show you 100% of the CPU, right? Because they are actually forwarding this packet again and again and again, right? Everybody is sending this packet again and again and again, right? And I am saying this is the CAM table of switch 1. This is the problem number 1. And this is a huge problem, right? So if we have a physical loop in the system, what is the meaning of physical loop? If you can see that we have these 3 switches, switch 1, 3, 2. If they are connected like this, it is inevitable that if somebody is sending ARP, it is going to loop around the system, right? Right? But it should not be the case. If that is going to happen, who will buy these switches? Because these are not doing anything, right? But now consider another problem. If I want to showcase you with this pink line, that host A is sending the packet, the address resolution packet, and that is why I built this table. That's A.A.A is connected to 0/3. This packet is going to go over 0/1, coming back like this, and now it is again coming back like this, the same packet having destination address of FFF, but the source address of AAA. And you know That switch builds the CAM table on the basis of incoming frames, source address. The frame was, destination was all Fs, and source was a.a.a. It was coming over 0/3 as well as 0/2. Now after looping, if that is the case, this switch is going to be confused that now 0/2 is connected with a.a.a. This is called the MAC address flapping problem, because previously this MAC address was connected to 0/3. Now it is connected to 0/2. Which MAC address to believe, right? It cannot be the case that over a switch interface, you are going to see that this MAC address a.a.a is connected to 0/3 and now it is connected to 0/2. You cannot say that this MAC address is connected to 0/3 as well as 0/2. This is wrong, right? If you have two different interface, one MAC address cannot be on both of them. So what switch does? It is going to choose the most recent entry. But whenever there is again a loop, or whenever it guys send again an ARP message, right? It will again say I'm connected to 0/3. It is going to create the problem. And this problem is known as flapping issue, MAC flap. MAC is saying sometime I'm connecting to 0/3, sometime I'm connecting to 0/2. It is a problem. Everybody is going to deal with this problem, right? Because here the ARP message is coming like this, and now the same ARP message is coming like this. It is a problem for switch 2 whether it is learned this information from 0/1 or 0/2. Try to understand. We have three problems. One is loop, which is leading to CPU utilization, 100% CPU utilization. The second problem is MAC address flapping. And by the way, guys, the ARP which you are seeing here, the flooding of the ARP, we are also call this as address resolution protocol flooding, which is leading to the loop. It is as simple as that. First thing first, I really want to ask, did you get something out of this board? Do you understand the problem first? Because the discussions which are going to happen after this are going to be they are going to solve only this problem. If you understand this problem, then you might think something, right? So I would definitely maybe I want your input in this, right? Suppose we have these three switches, switch 1, switch 2, switch 3, anybody, right? And they are connected like this. We are having this problem of looping. Why? Because we have this physical loop, right? Packet goes from here to here, then from here to here, and then come back from here to here. Can anybody of you, because now you understand the problem well, can anyone suggest me here what should be the solution for this problem? Anybody? This is a question for you all. I would say, I think Rachit has raised hand. Anybody else can explain this for me? That not explanation. I am just throwing a problem that the problem happened because there is a loop in the system, right? Physical loop. We have three interconnected links. Can anybody suggest? I am just asking for your suggestions. Can you suggest me that how basically can I break this loop, or how can I solve this problem? What do you think, right? If you are not raising, I think Sparsh, have you raised your hand or? Okay. Hemant just raised the hand. Hemant, if you can go, if you want, just unmute yourself and please ask, please say something. Yeah, please go ahead.
Basically, we try to break the loop.
Yeah,
That is the one solution I can think.
how basically we are going to break that rule? What do you think about it?
Like as I can say, there is an no need of like link between switch 2 and switch 3.
Perfect.
So
perfect. Yeah, go ahead.
So if you connect only two like link between switch 2 to switch 1 and switch 1 to switch 3, then it will be work. It will work also fine.
Absolutely. And thank you so much for your explanation, right? You got the problem, you have solved the problem, right? But Hemant, if I say that this link is very fast, this is my 10 gig link, right? And this link is also very fast. I am just throwing some questions on you, right? And without going into the technical details, I want just means in layman terms, what should be the solution? You are saying that switch 2 and switch 3 link should not be there. If it is not there, then we are eliminating the physical link. If somebody sitting here wants to talk to switch 3, why do they need a direct link? Why they cannot come from here to here, right? And I totally agree with you. I totally agree with you. But now my question is on what base we need to decide that this link should go down, right? Because somebody is here, they have connected because customer doesn't know about it. They are just connecting switches with switches, right? They can create this, and if they can create this, they can introduce the loops into the system. And what we can do, we can write some code on this switch, right? Which is going to shut down this link if there is the case, right? And if this is the case, then basically, if this link is not there, then the arc will go from here to here, come from here to here, but never going to loop around. And thank you so much, Hemant, for your answer. But now I am just creating this problem a little worse, right? Suppose this was my 10 gig link, the huge link, right? This is only 10 Mbps link. There is a huge difference between Mbps and gigs, right? And it is also my 10 gig link. Suppose. What do you think, guys? Should I shut down this cable? If I write down the cable number, this is 1, this is number 2, this is number 3. What do you think? Which cable should I shut down? If I shut down the cable 10 gig, then it is going to be a problem, right? And I want actually your suggestions. I want to have a discussion with you on this. I totally agree with you that I need to remove a link from somewhere, right? To avoid this. But I'm saying that this link is faster, so I want to keep it. This link is faster, I want to keep it. Which link would you be looking to shut down? Anybody? Okay.
Link 2, I guess.
Who said this?
Gopalesh.
Gopalesh. Very good. Very good. Right. Link 2, because this is the slow link, right? So you all agree with me that there is a solution to this problem, right? We should not let the physical loop to build, and we are going to remove that link which is not that much useful, right? Do you all agree with that? I want a hand raise. Perfect. You all agree to this, right? And that is how we are going to solve this problem. We are writing a code, we are writing the code into these switches so that these switches are capable enough of knowing, first thing first, they will remove the link if there is a loop, and second thing, they are going to remove the link which is not that great, right? But suppose if something happens, suppose you are saying that now this link should be down, this second link should be down. Suppose in a case, if this link goes also down, the third link, what is going to happen? Then switch 3 is not able to reach to switch 1 and switch 2. It is as simple as that, right? But this is the switch which is shut down by the software itself because you have written the code. And now this link has some problem. This is going down. Maybe somebody has plugged out the cable. Somebody has taken this link out, right? So your software should be capable enough to know that now there is no link between switch 2 and switch 3. I need to make this up, right? Although it is just a 10 Mbps link, but it is the only way switch 1 reaches to me, right? Why? Because now there is no switch 2 and switch 3. There is some guy who is accidentally, who is deliberately maybe plug out this cable. If that is the case, then the link between switch 2 and switch 3 is not there, and the software has shut down this link, 10 Mbps link. Now it is the responsibility of your software or the code you have written on these switches to make this link up again. It is as simple as that, right? Somebody is saying, the Shubha Sharma, how about we connect only 2 switches out of 3? Yes, you are right. This is the solution. Interesting, right? And by the way, guys, whatever the code I'm going to write on these switches, this is known as a standard because all switches should understand it. And that code which is written as a standard is known as spanning tree protocol. Spanning tree protocol is actually will do this for you. It is going to eliminate the link which is going to form the loop, and it is going to eliminate only that link which is not that useful, right? So if I again explain you this problem, right, over, although you all get this, actually I created this board that if you have something in your mind, right, confusion, then basically you should be seeing this board. We have 3 houses, house C, house A, and house B. Now I'm talking about, if you want, if there is a person who lives in house C wants to go to house A here, right? This person name is C, this person name is A. How it will go, right? It will select a direct path 10 kilometer long, and it will go like this because to him this is the best path. But now before going to house A, it has just opened the GPS and see that there is another path, although you need to take 2 roads, but still the distance wise it is only 9 kilometers. And if I am moving less distance, then basically it is less costly to me because my petrol is going to be less, right? The spend I will do on the petrol is going to be less if I choose the second path. This is path number 1, this is path number 2. So I would not say that to take path number 1. GPS is going to say path number 2 because it is still 9 kilometers to reaching Jose, right? So first thing first, in the previous topology, we need to avoid the loop, and we need to avoid the loop in such a way that we are only shutting down that link or that cable which is not that useful. In this case, if I consider these roads as the cable, 10 kilometer cable, I do not want to go, I need to shut it down, right? If I say it's a cable, but unfortunately it is a road, I cannot shut it down. It is going to be there, but I will be choosing this path because it's the shortest path. The definition of the shortest path is the path which is having low cost. That cost can be anything here. The distance is the cost. The lesser the distance, right, the lower the cost is. It is as simple as that, right? So what we are going to do is we will be covering the spanning tree. Now you understand the problem. I would highly encourage you to go on my YouTube channel or to go on my website to see a video how to avoid loop in layer 2 environment, right? I will be covering this is tomorrow's session, but if you want to know how software is doing that, you will be amazed to see. It is very, very interesting, right? I can explain you that right now. There is a specific algorithm to solve this problem. I think you have heard about spanning tree, because if you have a tree-like structure, it is not going to have loop. And we are talking about spanning tree protocol, which calculates the shortest path tree. If you do not get what I'm telling, what I just said, do not worry about it. But I'm thinking that you are engineering students, so you must have heard somewhere trees or the spanning tree, something like that. If you haven't, do not worry, because at the end of the day, you all know that whatever this spanning tree protocol is doing, it will shut down one of the link, which is not that useful to us. That is it. That is what it is doing. But because now we are not doing it, it is done by the computers or these switches. And how a computer work, you need to tell them a step-by-step approach, what link to reduce, right? What link to shut down. And that step-by-step approach is known as algorithm, which we are going to talk about tomorrow's class, where we will be talking about spanning tree protocol, which is going to remove these loops from your system. Interesting. Tomorrow also, we are going to cover one interesting topic, which is known as Ether channel. And tomorrow itself, we are going to start the routing also. Having said that, this is what I had for today's session. But just wait for a minute, because Punish has some cool stuff to showcase you. Whatever we have learned today, yesterday, or day before yesterday, right? Maybe last week. Punish will showcase you all those things right there in action on Packet Tracer. Okay. And by the way, guys, I have given almost 40 to 50 people access to my website. So there are two sections of the CCNA. CCNA theory there and CCNA practical. So whatever we are reading here as a packet tracer or something like this, with the expert like Punish and Dhaval and Rohit, right? These sessions are going to be available in hands-on part. Hands-on means you are doing some practicals, right? So I would highly encourage you to just go onto the website. The guys who have registered till day before yesterday, I have given access to them. Just click on Enroll CCNA, absolutely free, and then you are going to get this, right? Two things, CCNA theory, CCNA practical. The practical thing is going to include all the packet tracer sessions like Dhaval's, like Punish, right? We will be putting them there. Okay. So I think there is one more question, Punish, I think we have, right? So while creating any topology, should we always avoid designing cyclic networks? If you can do that, that is going to be great. But if you do not do that, there is a protocol by default runs, which is known as spanning tree protocol, which takes care of that, because now Mr. Mr. Nayak, right? Now you know that there could be a loop if you connect, but the customer maybe they do not aware about this, right? They do not know the CCNA level thing, and it could be possible, right? They can connect it. Now you know that I do not need to connect like this cyclic manner, right? Or the loop manner, but customer might not know about it. And that is why we are going to learn by default the spanning tree protocol, which will take care of these loops thing, right? But we need to understand this, how spanning tree protocol is going to work. But again, the question, Mr. Nayak, is really, really cool. This is very, very good question. And thank you so much for it. Having said that, Mr. Punish is all up to you. Okay? Can you hear me?
Thank you, Vishnu.
Yeah. And before that, Punish, so I will take another 10 minutes of your, I have started the recording once again, so that there are some doubts, right? That how Punish has created this topology in Packet Tracer, right? One by one. Punish could have easily resolved your query, but actually I want to do some whiteboarding on this topology so that everybody be on the same page. So I would like to ask, means whether you are here, means can you just raise hand? I would need another 10 minutes of yours. Perfect. So we have everybody here. This is good. Let's talk about, and Punish, if they have any question, please let me know, right? So this was the topology. I just taken screenshot from Punish Packet Tracer, right? And it would be great, first thing first, if you can go through the hands-on session, hands-on part of this course to know what Punish has done there, right? So here is the step-by-step approach, how you are going to create this network, right? I think this question was asked by Rachit, that can you just guide us with the command? Even Monica is asking. So I would definitely not telling you now that how to bring these devices into this frame, right? Into basically into this here. You just need to drag and drop. You just need to drag and drop these switches, as simple as that. And then you need to drag and drop these laptops from whatever we have here, right? Something from the devices you need to just drag and drop here. Once you have done that, you need to connect using you can use the default cable, which is not, if you are not sure about which cable to connect, whether it's a straight through cable or the crossover cable. But if you have gone through the concept, you should be understanding by now that the PC and the switch are going to connect with a straight through cable, right? And basically the switches are going to be connected using the crossover cable. Why? You need to go to the classes. But if you do not want to look into this matter like straight through a cable, you just need to just take a default connection and it will take care, because most of the recent switches are now enabled with the MDI auto MDIX feature, which can take care of your cabling requirement. Once you are done with this cabling, because I think we should all be, right? As you can see that we have two ports on this switch, FA0/4 port and FA0/3 port. FA0/3 port is part of VLAN number 1. So what you need to go to this switch, just go inside this port, right? First of all, what you need to do is you need to create a VLAN. Maybe you can say VLAN, right? And then define the name of it. By default, VLAN 1 should already be there, so you do not need to define it, right? But you need to define the VLAN 2. So you are going to write the VLAN 2 here. So your VLAN 2 is going to be created on the switch, and now you need to assign the interface. So step number 1, create the VLAN. Step number 2, assign the interface. What you need to do is go to interface FA0/4, right? And of course, you should be in the configuration mode for doing that, right? You understand that, right? You need to write conf t, and then basically you need to write interface FA0/4. And now inside this interface, you need to write switch port mode access VLAN 2. It means that now this is going to be part of your VLAN 2. Suppose this was VLAN 3, then you need to create the VLAN 3 and make this interface as a part of VLAN 3. By default, all the ports of the VLANs are going to be part of your VLAN 1, right? Similarly, what about these interfaces? I think, Punish, these interfaces are, you haven't configured anything on it. This was already trunk, right? By default?
That's 0/1, 0/2.
Yeah.
Yeah, I have configured
Oh,
it.
you have configured. So basically they have
Yeah.
not doing the automatically, right? So for these interfaces, just go to, you need to make these interfaces a trunk. But before making them trunk, you all should know that this laptop interface and this laptop interface, FA0/2 and FA0/3, you need to repeat the same step. This should be part of VLAN number 1, which is by default. This should be part of VLAN number 2, which you need to go to FA0/2 and make them switch port mode access VLAN 2. It is as simple as that, right? Now, to make this interface as a trunk port between the switches, you need to go over this switch, go into this interface FA0/1, just write down here switch port mode. What is the command? I think, Punish, can you tell me the command? Switch port
Mode trunk.
switch port mode trunk. First of all, you say trunk, and then you need to write switch port trunk. I think encapsulation also we need to give, right?
So I think in this packet tracer, as soon as we give the trunk,
Yeah.
it will by default allow all the
Oh, by default allowed.
VLANs.
Okay,
Yeah, yeah.
just you need to configure trunk here, you need to configure trunk here, and that is it. Punish can show you these commands also, right? That is fine. But this is the entire way. I should think that you should do this on your own time, right? Now you have more than 4 hours. It is up to you that if you can spend another half an hour creating this topology and try to ping these devices. If you do that right now, believe me, whatever we are doing from last 1.5 weeks, right? We have already spent around 20 hours learning few of these things, right? Believe me, if you start doing this along, then it is going to be great for you. Otherwise, the time means if you do not do it right now, it is going to be more difficult because you do not remember the concept. To make your concept even solid, just try to make this lab. And one more thing, if we forget something, right, do not worry. And the reason is we always have Google, right? Suppose I forget about that how to make this two interfaces trunk. Write the same question on Google, because now you have the understanding of at least trunk. What is trunk, right? But you do not know how to configure that. What is the command? You cannot always remember all the commands, and that is perfectly fine. We are human beings, right? It should not be that we should learn and remember every command. It is as and when it is required, just figure it out that how to do that. If you write trunk configuration, Cisco switches trunk configuration, the first thing which you are going to get is this one. And I make sure that once you are reading those commands, how to configure it, it is my responsibility that you understand that command, right? Why? Because we have understood the concept. So today I would expect everybody to create this lab, make the links between switches as trunk, right? Just assign the IP address onto these devices. Choose to any VLANs, VLAN 20, 30, 40, right? Create even 3 VLANs. Just try to make sure that the PCs in those VLANs are going to communicate with each other. Doesn't matter where these are. But if they are in same VLANs, they should be able to communicate with each other. As you can see that we have also discussed today about a major problem in the switching network. Punish is showing you this is the topmost switches, this is the left switch, and this is the right switch. If you can see right here, Punish hasn't run any spanning tree protocol, but still the packet was not going over this interface from here to here. Why? Because your system, your switching system, the code which is running spanning tree protocol has blocked this one. Why it has blocked this one? We will see it later. But I want to showcase you that this port is actually shut down by the system itself, because you can see the orange color here. Although there is a green color from here, what is the meaning of it? We are going to learn it in tomorrow's session. If you have any doubt, any question, because I'm going to stop the recording now. If you have any doubt, any question, please do ask. Anybody? Punish, do you see any question from anyone?
I think that was the last, yeah, which you answered.
Perfect. Having said that, enjoy your day. Bye for now. See you tomorrow sharp at 9:30. Bye-bye.